Alright, so this very short chapter is on variation. Alright, and basically variation is just another word. It's a fancy word for change, how things are changing. Okay? So this chapter, there's just two kinds of variation we're going to learn about, direct and inverse. But for this podcast, we're just going to focus on direct variation. Okay? So basically, here's what direct variation is. Here's the formula, first of all, for direct variation. Y equals k times x. Okay? And the way we would read this is actually pretty important to get down because it's going to help you with the word problems. It's y equals kx, but the way we would read it, this says y varies directly with x. Okay? Because these are your two variables. We could have any two things that we're comparing, but this is showing that they're varying directly. Okay? And here's what direct variation really means. What this means is, and you might want to write this down, it's just a quick note, but if my y goes up, then my x will do the same thing and go up. If my y goes down, my x will go down. Direct variation, that means the two variables are changing the same way. Okay, so like a real life example would be, let's say that we are going to the store and buying something. So let's say we're buying fruit. Well, if y is my fruit, the more fruit I buy, then the more money I spend. My money goes up. They're basically changing the same way. Okay? On the other hand, like let's just say y and x. Let's say y stands for how much I study. So if the amount I study goes down, then x would be like my grade. My grade would probably go down. The less I study, the lower grade I get. Okay, so when two things are in direct variation, they're just changing the same way. Okay, and so that's what this equation will allow you to do. Okay, now this new letter, the k, it stands for the constant of variation. That's just showing you how much it's changing by. Okay, so if the constant is 2, that means everything's changing 2 times, basically. Okay. And it's actually kind of similar, just to tie this into the graphing you've been doing the last 2 chapters. Remember this formula, y equals mx plus b. Well, basically, instead of the m, we have a k here. K times x instead of slope times x. And basically, it's kind of the same thing as the slope, because slope is how something changes, and the constant is how it's changing. And so, being that we're talking about graphing here, a graph of a direct variation line, it's a straight line, and the k is the slope. Okay? Now, here's the other really important part of this graph. It's a straight line, but the graph of direct variation, it has to go through the origin. Alright? And remember, the origin is the very middle, 0, 0. And if you think about it, if I come back to here, I have y equals kx. I don't have a y-intercept. That's why it's like plus 0. Okay? But this is what you would use for direct variation. So let's look at some examples here. Okay. Now the first thing we want to do is be able to look at some equations and identify if it's direct variation or not. So here the directions say determine whether each equation represents a direct variation. If it does, find the constant of variation. Alright. So if we look here, now what we want to do is it has to be in y equals form. Okay. So if we look at this first equation, number 1 says y equals 2x. This looks just like y equals kx, right? Everything's lined up. So I'm going to circle yes, this is direct variation. And then it said if it is, find the constant. Well, what's in the place of the k? 2. My k is 2. Okay? Basically, the k is the most important part of the equation. Okay, so that's why we're kind of focusing on that here. Alright, now this one, number 2, we have 3y equals 4. Now I can't say yes or no until I get it into y equals form. Okay, so sometimes we have to solve for y, just like with the graphing. So before we can look at this, 3y, let's get rid of the 3 by dividing by 3 on both sides. When I do that, I'm left with y equals 4 over 3. Now I'm going to look at that. Is that direct variation? It's pretty close, but it's no, because we're missing a very important thing. There's no x. Got to have that, everything in that equation. Alright? So because it's not direct variation, there's no k, there's no constant. All right, let's go to the next one here. Now we have 2y equals 3x plus 5. All right, so let's always just go through the steps. Y is not by itself. We're going to solve for y by dividing everything by 2. So here I'm left with y equals 3 over 2x plus 5 over 2. Now let's look at this. Is this direct variation? And here the answer is no again, because there is no plus or minus after the x for direct variation. If it just said y equals 3 halves x, then that would be okay. And we can have a fraction for the constant. It's this times x. But because of the plus, it's not. Okay? All right, let's look at number 4. Negative 3 plus 4x plus 3 equals 2y. Got to solve for y, but let's look here. We can combine our like terms. Negative 3 plus 3 means 0, so those cancel out. I'm left with 4x equals 2y. Now I got to do one more thing. Now careful, we don't want to divide by 4. I'm not solving for x, I'm solving for y. Okay, so let's go here to the y side. Divide both sides by 2. Y is gone on this side, or 2 is gone on that side. 4 divided by 2 is 2, and then the x is there. Now if I look at that, and remember, I can use my symmetric property. I can just kind of reverse it here. This is direct variation. And once again, the constant is 2. I know that's kind of weird. The constant will not always be 2. It's just that for these problems it was. Okay? So that's what you have to do to identify. You got to set it to y equals. Alright, so now let's get to some simple solving here. Alright, so now it's telling you. Okay, this is important. Suppose y varies directly with x. They're telling you it's direct variation. So when they're telling us direct variation, then right off the bat, in your head you should be thinking y equals kx. That's the formula for direct. Now it's going to say, write a direct variation equation that relates x and y. Then solve for the missing variable. Alright, so this is a two-part problem. Okay, they're going to give us some information. They're going to give us the y and the x. We're going to plug it into the formula, solve for the x. Then we're going to use the k. Once we find the k, we're going to plug it into an equation and then use that new equation to solve for one of the variables. Okay, but it's all about finding the k first because you have to know how much it's changing by. Alright, so if we go through here, let me enlarge this real quick. Okay. Alright, so number 5. Here we have y equals 10 and x equals 5. So I'm going to plug these values in. Okay? So that means, remember, it's y equals kx. I want to plug in a 10 for the y equals k times x is 5. So see, I have the y and the x. So I'm not solving for y or x. My only missing variable is the k. That's what I'm solving for. So because this means k times 5, I'm going to divide by 5 on both sides. Got to solve for that variable that's k. K is alone here. 10 divided by 5 is 2. Once again, it's 2. It's not always going to be 2. So my first step was finding my k. So what am I going to do with the k? Now when they say write the equation, technically y equals kx is not the equation. That's just the formula. The equation is when you have the k. So my new equation is y equals 2x. Okay, now that I have my k, it's an official equation. Now I'm going to go to my last part. Now it asks us to find x when y equals 12. So look at this equation. I'm going to plug in 12 for y. And y equals k. Now my k is 2 for this equation. X. We're finding x. And so now this is easy. I just solve for x by dividing by 2. X is by itself. 12 divided by 2 is 6. Okay? So you see the sequence? You find the k first, plug the k to the equation, then I can use that equation and plug in any value of one variable and get the new one. Okay? And once again, look what's happened here. Look at what the y was. The y was 10 and now it is 12. So look, the y went up. Then look at the x, 5 to 6. The y went up. Direct variation, things change in the same way. They both went up. Okay? Alright, let's try another one here. So now, it's still direct. So when they say y equals 6 and x equals 7, I'm still using y equals kx. Y equals kx. And now we're going to solve for k. K times 7, we divide by 7. Okay, all right. So my k is just going to be 6 over 7. And that's okay. We can have a fraction for the k. All right. So now when I write my new equation, I'm going to write y equals 6/7 x. Just like slope can be a fraction, constant can be a fraction. Now I'm going to use this formula and solve for x when y equals 6. All right, so if y equals 6, it's going to be 6/7 x. Okay? All right, a couple ways you can handle this fraction. You can do it in 2 steps. You can multiply by 7 to cancel out the bottom, then divide by 6. I'm just going to do it in 1 step. Okay, but just to show you a different way, and the calculator will help you here. But technically it's 6/7 times x, right? So just because it's times, I'm going to divide by the same number. Here it was 2 times x, we divided by 2. Here it's 6/7 times x, I can just divide by 6/7. Same process, even though it's a fraction. That cancels out. X equals, now here's how you're going to use your calculator. We're going to go type this in exactly as it says, 6 divided by 6/7. And I'm going to use the fraction boxes for that. So if we go to our calculator, okay, so here it's going to say 6 divided by, and then we put the fraction boxes up. Choose your n over d. So 6 divided by 6 over 7. And that's going to equal 7. Okay? So in this case, our x equals 7. Okay? All right? And let's do one more example here together. So now we're looking at if y equals 3 when x equals 6. So we're going to plug those in. Y equals k times x. And now we're going to divide by 6. And 6's are gone. If I take that 3 over 6, remember, always simplify your fractions. Put that in your calculator. It'll say 0.5. Put it back to a fraction. The simplified fraction is 1/2. So my k is 1/2. So I have another fraction for my k, and that's okay. So now it's y equals 1/2 times x. That's my equation officially. So now we're going to use this new equation, and we're going to find x when y equals 8. So it's going to be 8 for y equals 1/2 times x. So think about what we just talked about. This is a 1/2 times x. The opposite of times is divide by 1/2. And if we divide by 1/2 on both sides, x is by itself. Let's go to our calculator. 8 divided by 1/2. Okay? 8 divided by 1/2. Do this with me so you get comfortable with it. 1 over 2. We see that it's 16. Alright, so in this case, x is 16. Alright, so on the next page, what I want you to do is to pause the podcast. I want you to try numbers 8, 9, and 10. This is still the same kind of problem. We are still using direct variation and going through the steps and making a new equation, then solving it out again. Alright, so pause it, try these 3, unpause it to check your answers. Okay? Alright, so here are the answers for 8, 9, and 10. So it starts off with getting your k right. Plug the k in, use the new equation to solve for the missing variable. Okay? So take a look at these 3, and then, just another thing we kind of talked about, not on every problem, but before, remember direct variation changes the same way. Look at number 9. We started off with y is 16. Y ended up being -8. That means y went down, right? So x should change the same way. X was 8, it's -4. So when the y went down, the x went down. Other ones, when the y went up, the x went up. So once again, direct variation, the 2 things were changing the same way. Okay? Alright, if you had any problems on these, definitely come see me before you go into the next video. Okay? Alright, but now let's kind of take a look at some graphing. Okay? Now here's the one, really the most important thing you have to remember. Direct variation. It's a straight line all the time, and it always goes to the origin. Okay? If it doesn't do those things, it's not direct variation. Okay? But these are going to be direct variation. It's just asking us to graph it. Okay? And you've been graphing the last 2 chapters. So I just treat it the same way. Y equals 2x. So once again, there's no y-intercept. It's plus 0. So I'm going to put my dot at the origin. The slope is 2, which means 2 over 1. I'm going to go up 2, right 1. And then I take my ruler, and then I make my straight line here, and that's my direct variation. Okay? Very easy. It's just like graphing. Number 12, y equals 1/2 x. Y-intercept is still 0. Now my slope is 1 over 2. So the rise is on top. I go up 1, right 2 from here. Up 1, right 2. Up 1, right 2. Okay? Then we're going to get our ruler, and we're going to connect our dots. Okay? Alright, and last one. 13, y equals negative 2/3 x. So our y-intercept is at 0 again. Now remember, this is negative 2/3. Remember, there's two ways we can do this. I can put the negative on the 2, or I can put the negative on the 3. When you're dividing, one negative number makes the whole thing negative, right? Not both negative. That would be positive. So I'll just do both ways here. So this one would be down 2, right 3. So if I start in the middle, down 2, right 3. If I do the other way, it would be up 2, left 3. Up 2, left 3. Okay? So either way, you can see that it's still going to fall into like a nice straight line here. And there's our direct variation. Okay? Alright, so that's pretty much it for direct variation. Okay?